Hello, my name is Maximillian, and I'm currently a third-year computer engineering major at UC Santa Cruz. This past summer, I joined LiveHD, a productive infrastructure used for live hardware development that aims to provide synthesis and simulation results in seconds. This project is led by Professor Jose Renau and student project leader Shanghong Wang. LNAST, or Language Neutral Abstraction Text Tree, is a high-level intermediate representation that helps to bridge different hardware description languages and high-level synthesis into LiveHD. For HDLs like Pyro, Verilog, and for RTL, it is necessary to check that operators and operands are properly represented and structured in LNAST. As a researcher for LiveHD, my goal was to implement semantic and miscellaneous checks on LNAST. LNAST semantic miscellaneous checks include general checks on LNAST operators such as arithmetic or logical operations, control flow statements, and functions. Out-of-scope variable checks, variables that are read but not initialized or defined in the current scope. Never read variable checks, variables that are written to but never read. Last write variable checks, variables that are read but never used. Never write variable checks, variables that are read but never written to. And inefficient LNAST variable checks, variables not affecting the program but are necessary. With the tree-like structure of LNAST, the most straightforward method to implementing checks is to visit every single LNAST operator node, or node that corresponds to a specific operator, such as arithmetic or logical operations, and check the number of descendant nodes and descendant node types. Here's a simple if, elif, else statement, and here's the same statement in AST form from LNAST. Here I'll go through an example of the LNAST semantic check. Suppose you have an addition LNAST operator node. It is expected to have at least 3 descendant nodes, 1 for the left-hand side and 2 for the right-hand side. The semantic check will detect from the minimum number of descendant nodes, which in this case is 3. This minimum number does vary among other operations. For miscellaneous checks like inefficient LNAST variable checks and out-of-scope variable checks, it became necessary to use data structures like stacks for out-of-scope variable checks, flat hash maps and sets for never read, never write, last write, and general variable checks, and arrays for all variable checks. To tie together the semantic and miscellaneous checks, error or warning messages need to be displayed for each check if they are not satisfied. For each check, LNAST is printed in AST form with arrows indicating possible variables that have triggered errors or warnings, and a short message conveying the type of error or warning. The purpose of these checks are meant to inform developers of potential warnings and/or errors that may affect their programs. Additionally, these checks can also serve as feedback for our own developers of potential LNAST implementation issues or possible improvement to the design and architecture of LNAST. In addition to LNAST checks, I have yet to work on updating the LNAST API documentation. I plan to update the documentation with more details of LNAST operators using GraphViz, a graph visualization software, and add new details on the usage of semantic and miscellaneous checks. The LNAST API documentation is incredibly important for developers and users to reference when using LiveHD. During my time with LiveHD, I've learned so many new things. This is my first time ever contributing to an open source project, and the experience was rewarding and eye-opening. Actively working on something that has so much potential, like LiveHD, is truly fascinating. In developing the LNAST semantic and miscellaneous checks, I have learned to use Bazel to build LiveHD, to read and utilize pre-existing code and tools written by others, to familiarize myself with the underlying structure of abstract syntax trees, and most importantly, to be confident in both the work I do and in myself. I want to thank Professor Renau, Shang Hong, and many other researchers, including Hunter Kaufman, who have stepped in and helped me a great deal. I truly appreciate and am grateful for all the help that I've received. Thank you for your time, and thank you to Cross for a chance to speak about my work.